mortality events, otherwise known as wrecks, involve predominantly seabirds around the world and have been recorded since the early 20th century. The causes of these wrecks were often due to things like oil pollution or lack of food, which in itself was often associated with climate and ocean warming events. So in light of climate and ocean warming events, there's been this kind of emerging perception amongst the seabird community that wrecks might be increasing in frequency. However, the quantitative data that we need to support these perceptions has largely been lacking. So using the literature on Ardenna mortality events, a genus of seabird that commonly wrecks all around the world, we worked together as a team to identify what data elements have been reported for seabird wreck events to date, such as the duration of the event or the amount of search effort that's been put in. And we also worked together to establish the minimum data fields that we as scientists need to be reporting for all future wreck events. Systematic literature reviews are fairly common in ecology, but these tend to be focused almost exclusively on the peer-reviewed literature. So for our study, we also did this, but uniquely, we also invested a significant amount of time and effort in compiling data from what's called the grey literature. And this meant for our team searching for and reading general interest articles from things like newspapers and blog posts, including the Pacific Seabird Group's own listserver. And it was important to include this grey literature in our paper, as there is a significant time lag between when a seabird wreck event occurs and when the details or the data from that wreck event are later published in the peer-reviewed literature. For example, articles on the 2013 to 2019 marine heat wave in the North Pacific Ocean, known as the Pacific Blob, have only recently been published after a delay of around 3 to 5 years. However, one of the things we were also very interested in investigating is whether there's a trade-off between accessing the more rapid or timely information that's available in the grey literature, like newspaper articles that are really quick, and the quality of the data that you get in those newspaper articles and blog posts. In other words, do newspaper articles and blog posts include robust quantitative data, or perhaps do they tend to be a little bit more quantitative? Well, our results demonstrate that there are overall a very limited number of both peer-reviewed and grey literature articles on seabird wrecks globally, despite the perception that there is an abundance of this literature on this particular issue. So despite all of our extensive searching, in total we were only able to locate 80 articles on seabird wrecks dating back to the mid-1980s. Most of these articles, importantly, failed to report the quantity of beach-washed birds and instead stated simple things like a large wreck or just simply reported that a wreck event had taken place. The grey literature, such as newspaper articles, tended to be on the lesser of the quantitative spectrum, or in other words, more vague on average compared to our peer-reviewed literature. And this is not entirely unexpected, as a broader audience, like those that would read a newspaper, are likely to be more interested in where or maybe why a seabird mortality event took place than precise details that scientists might be interested in, such as the exact number of birds or the number of people and teams of people involved in making those observations. However, even for the peer-reviewed literature, these basic but really fundamental metrics, such as areas searched and even the seabird species composition, also tended to not be reported, which for us was really surprising. And this is obviously an area for significant improvement in future studies. Importantly, overall, we currently lack no real official definition of things like a large wreck or a small wreck. And what qualifies as large or small likely actually depends on the size of the seabird population in question. So a really great example is here in Tasmania, the total number of short-tailed shearwaters is on average more than 200 times the size of the total population of flesh-footed shearwaters. So short-tailed shearwaters are much, much more abundant than flesh-footed shearwaters overall as a species. So if you have 500 dead birds on a beach, those 500 dead birds are a much bigger concern for the one species than another, at least from a demographic perspective. Right, so given everything we've learned from this paper, to ensure future studies provide more robust data on seabird wreck events, we proposed a new grading framework for reporting of seabird and perhaps even other species mass mortality events by categorizing three main things: the biological, spatial, and temporal extent. So what do I mean by this? Well, the biological extent we defined as the percentage of the species' total population that was actually caught up in or involved in the event. And this ensures that the framework explicitly incorporates the species' population size, allowing that threshold to be adjusted appropriately. Now, many wrecks typically comprise of just one predominant species, at least in seabirds, with lower numbers of other species. Thus, the grade that you as a researcher might apply for biological extent can and should vary for each of the species involved, even if the spatial extent, which I'll talk about in a second, are the same. So the spatial and temporal scales also are essential in quantifying the scale of these events, and by recording these in detail, that will facilitate future studies to potentially identify the cause of the event, so our ability to link it with things like ocean warming events. Interestingly, not very long after publishing this paper on establishing a framework for reporting of seabird wreck events, we actually experienced a seabird wreck event here in Tasmania, with many dozens of fairy prions washing up on a handful of beaches after an ocean warming event. And we were able to put our proposed framework into immediate effect, ensuring key information such as the start and end date of our event here in Tassie, and even the search effort. So how many of us were involved in the search and how much area we searched. So all of that data was captured because of this new framework. Now, the inclusion of these three different extents, the biological, the spatial, and the temporal, enables us to encompass a more complete and comprehensive definition of wreck. What is a large wreck, or what it would be a long duration of a wreck event, than simply how many birds washed up on a beach, which is what we're currently doing. And critically, this new framework allows for the magnitude of that wreck event to be quantifiable data, without the need for our reliance on long-term data sets to be able to figure out normal from abnormal events.